Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try to find the answer to this question yourself, pause the video now. If you got the answer A, well done. If you'd like to hear my explanation of how I found the answer, please continue watching. So a solar panel transfers energy at a rate of 1.2 kilowatts, the liquid passing through it. The liquid has a specific heat capacity of 4 kilojoules per kilogram per Kelvin. When the liquid flows through the solar panel, its temperature increases by 3 Kelvin. The flow rate of the liquid is. Okay, so first thing to look at is energy transfer rate, 1.2 kilowatts. Well, that's the same as 1,200, and a kilowatt is just a joule per second. So I'm going to use the equation that the thermal heat transfer is equal to the mass multiplied by specific heat capacity multiplied by the change in temperature. And I'm just going to deal with everything happening just in 1 second to start with. So if it's just happening in 1 second, the energy transfer is going to be 1,200 joules. So I can rearrange this equation to find the mass change in 1 second. Made mass the subject. Let's put the numbers in. Well, the energy change in 1 second I've just said is 1,200 joules. The heat capacity we're given in non-standard units, given it as 4 kilojoules. So I need to change that to joules per kilogram per Kelvin. So 4 kilojoules is going to be 4 times 10 to the 3. And then we've got a change in temperature of 3 Kelvin. I'll put that into my calculator and we get an answer of 0.1. Now, that would just be kilograms, but because I was working everything in 1 second, that's also going to be the number of kilograms that flows in 1 second. 0.1 kilograms per second. I hope you found this video useful. If you did, please press the like button. All comments be welcome, please. Any suggestions you have, like any questions you'd like me to go through, please leave below. And I hope you'll share this video and watch more in the series.